Alright class, in this lesson we're going to be taking a look at one-to-one functions, and that's because we need to worry about finding inverse functions. Now an inverse, in order to get an inverse, you had to have something that was one-to-one. What one-to-one means is that you have no repeating x or y values, whereas before a function, just a regular function, had no repeating x values. Okay, so that would have made a function. Now we're concerned about x or y values to make one-to-one. And it also passes what we call the horizontal line test, and what we had before was the vertical line test for a regular function. Okay, so the function test used the vertical line test, and it was concerned about no repeating x values. Now we do the horizontal line test also. And like a textbook definition would be that there's every x value corresponds to only one y value, and each y value corresponds to only one x value. So the way that looks on a graph is that all lines are one-to-one. Okay, so any line that looks like this, okay, this green line continues in both directions, that's one-to-one. Now another graph that would be a one-to-one would be something like this picture here. Okay, it's kind of an example of an x to the third graph. Now, most one-to-one functions are odd or have odd exponents. For example, this would be an odd exponent. This is actually x to the first power to get a line. An example of something to the second power would be like a graph of a parabola. Okay, this is a graph that is not one-to-one. A graph of a V is also not one-to-one. And these we've been dealing with recently, but they do not fall under this definition of one-to-one. So let's show why. Before we were looking at this first graph, in order to check that it was the old type of function, we were doing the vertical line test. And it passes that because there's no place where it touches twice on any vertical line. Okay, well now we've got the new test, so it passes the vertical line test. It also needs to pass what we call the horizontal line test, and we do that by drawing horizontal lines. And horizontal line touches at one place on the graph. Okay, and so what that means is that it passes the vertical line test and the horizontal line test, and every one of these lines I draw only touches the graph at one time. So this is one-to-one. So 1, 2, 1. Okay, now this blue graph, if I draw vertical lines, it passes that. If I draw horizontal lines, it also will pass that test. Okay, so this one is also 1, 2, 1. Now if I take a look at these graphs down here, they all pass the vertical line test. Okay, these pass the vertical line test, which means that they are functions. So functions check. But one-to-one, we have an issue because when I draw a horizontal line, I touch 1, 2 places. So I touch this one, 1, 2 places, which means these are not one-to-one. Okay? Now, pretty much any graph that is a standard x to the first, x to the third, x to the fifth, x to the seventh, all have one-to-one graphs. So pretty much everything after x to the first power looks like this, as long as it doesn't have any other numbers other than just x to the third, fifth, and seventh. Now these graphs are not always one-to-one. For example, if I had x to the third plus x, 5x squared plus 3x, and so on, this particular graph, if you had y equals that would actually have a picture that actually does some squiggling like that, where you've got 3 places where a horizontal line would actually cross. Okay, so if you drew some horizontal lines in here, that would not actually pass. So you can see that if you actually graphed it using a graphing calculator or if you had a graphing utility on your computer. But most of the time they're not going to be asking you anything this complicated, so you don't really have to worry about it. I'm just making a side note to say it's not always if it's x to the third, x to the fifth, or x to the seventh it's going to work out. Okay, but generally these are the types of things you're looking for one-to-one. So now we also have a question of whether or not we have relations that are one-to-one. Now this is called a function because we're assuming that there's no x repeats. well, not that we're assuming, is that these don't actually have any x repeats. For example, the -2, -1, 0, 1, and 2, those are all different x values. So this is actually a function. And the second relation is a function. G has 3, 0, 2, and 4. So that they are all different. So these are both functions. If they weren't functions, we would call them relations. Okay? And you might be actually called or asked the question, is the relation one-to-one? Well, first I'm checking to see if it's a function to make sure that all my x values are different. And now, to see if it's one-to-one, I need to make sure that all my y values are also different. So on the first one, I'm looking at 1, 0, and then I have 1 again. Now, because of the fact that there is a 1 here and another 1 there, and they're both y values, that means they repeat. So since I have a repeat here, this one is not one-to-one. Okay? So not one-to-one here. And now we look at the second one, and we'll see that we have 1, 2, 3, 0. All of those y values were different. Okay, so this one is actually one-to-one. Now I often have students they get confused here because they look at it and they say, well, I have a 3 here and I have a 3 here. But because of the fact that the first 3 is an x, the second one is a y value, it doesn't matter that they are the same number. It's just that the x values are all different. So x values are all different. And then on a separate note, the y values are all different. Okay? So it's not that the x's and the y's can't have any numbers that are the same. It's that the x's are different by themselves and the y's are different by themselves. Okay, so now I'm going to actually pause in this lesson and we're going to make a new lesson showing how to find the actual inverse now that we know that it is one-to-one.